My name is Savannah Lennon, and this is my review of the Week 10 readings on edX for Physics 2211. So, the main physics ideas for this week were that of the center of mass, kinetic energy, but it mainly focused on translation, rotation, and vibration. Rotational energy, obviously, point particle models, and multi particle models. New information for me was how to calculate the center of mass, what exactly the definition of translational motion was, internal energy, which is the total amount of kinetic and potential energy of all particles in the system. So, rotational and vibration are an example of that. Rotational energy and angular speed. Previously learned information for me was the concept of the center of mass, the energy principle, and Newton's second law. Some formulas they gave us that were very helpful were that of the center of mass. So, in order to find the center of mass, you can't just add up all the position vectors and divide it by how many there are. You have to multiply each position vector by its related mass and add those up, and then divide everything by the total mass of the system. And then angular speed's used in the rotational um, energy, and it's represented by the omega, and the formula is 2 pi radian over t. And then linear speed is 2 pi r over t. Rotational kinetic energy is equal to 1/2 I omega squared, and the I is specifically equal to the mass of each of the position vectors times. So this doesn't really relate to the neuroscience field, but I thought it was super interesting that you can take the center of mass of one object by dividing it up into a huge collection of like small pieces that can then be used as the point particle system. And then you basically just use the regular center of mass formula with the all the like tiny points in order to find the center of mass of the singular object. It doesn't really tie into neuro unless you're attempting to find the center of mass for maybe a person or their brain or something, but I still thought it was really interesting. The most confusing or difficult topic for me this week was the incorporation of the point particle and multi-particle systems in solving problems with the energy principle and just systems themselves. After all, I didn't have to use any of the supplemental resources because the last two videos of this week were the jumper example and the spring toy example, and they both did a good job at explaining and displaying how to implement the point and multi-particle systems into the problem. And basically, you just have to start with the point system, and then you move into the multi-particle system in order to solve the problems.